Good day, everyone. For today's lesson, our expected competency is to simplify radical expression using the laws of radicals. The objective of this lesson are the following. First, state the product rule and quotient rule. Second, identify whether a radical is simplified or not. Third, simplify radical expressions in such a way that the radicand contains no perfect nth root. So our topic for today is about simplifying radicals. Before we proceed to the proper discussion, let's have a history bites. Did you know that back in the year 1525, a sign was introduced by a German mathematician named Christoph Rudolph, and that sign is the radical sign or the square root. So let's start. The expression nth root of a is called radical, where the square root sign is the radical sign, n is the index, and a is the radicand. In mathematics, nth root of a raised to the power of m is just equal to a raised to the power of m over n. So by definition, we see that cube root of x squared is just equal to x raised to the power of 2/3. A raised to the power of 3 over 3 is just equal to cube root of a raised to the power of 3. X to the power of 1/2 is just equal to square root of x. And note, if index is not indicated, it is understood that it is 2. So let's identify the terms in a radical expression. A is the base or the radicand, n is our denominator of the fractional exponent or the index, m is the numerator of the fractional exponent or the power of the whole radicand. So let's have an illustrative examples. Write the following fractional exponents to rational exponents. First example, 5 to the power of 1/2 is just equal to square root of 5, where our index is 2, our base is 5. Second example, a raised to the power of 8 over 3 is just equal to cube root of a raised to the power of 8, where our index is 3, or we can say cube, and our base exponent, which is 8. Our example number 3 has an expression of 2x plus 5 raised to the power of 7 over 3, which is just equal to cube root of 2x plus 5 raised to the power of 7, which the expression 2x plus 5 will become our base and its exponent, which is 7. Example number 4, 7x raised to the power of 1/2 will become 7 square root of x. So why is 7 not part of the radicand? It is because the power is not a fraction and it becomes a numerical coefficient of the radical expression. Based on the examples given, the radicals square root of 5 and 7 square root of x are already in their simplest form, while cube root of a cube and cube root of 2x plus 5 raised to the power of 7 are not yet simplified. A radical can only be considered in simplest form when each of the following statement is true. So first, let's know what are those statements and the rules in simplifying radicals. To simplify radicals, we must consider the following rules and statements. Our first form is that all exponents in the radicand should be less than the index. Second is that the index and the exponents in the radicand should have no common factor except 1 or -1. Our third is that there must be no radical in the denominator. Let's proceed to the rules in simplifying radicals. First rule is the product rule, which has an expression of nth root of ab, which is just equal to nth root of a and nth root of b. We can separate both as long as the nth root of one term has a perfect square of the given. Next is the quotient rule, Then expression of nth root of a over b just equal to the nth root of a over the nth root of b. So let's have an illustrative examples. Example 1 is the fifth root of x16 y6. So how do we solve this kind of expression? So let's follow the steps. First is to use the product rule. So this will become the fifth root of x to the power of 16 times fifth root of y to the power of 6. Our step 2 is to write the radical expression as an expression with fractional exponent. So we transform the radical expression into fraction form or fractional exponent expression. So this will become x raised to the power of 16 over 5 times y raised to the power of 6 over 5. Step 3 is to express the exponent as sum of the largest integer possible and some fractions which is divisible by its index, that is 5. So this will become x raised to the power of 15 over 3 plus 1/5 times y raised to the power of 5 over 5 plus 1/5. Our step 4 is to use the laws of exponent. Recall that expression a raised to the power of m times a raised to the power of n, which has the same base, so we are going to just add their exponents, and it will become a raised to the power of m plus n. So the example will become x cubed times x to the power of 1/5 times y times x to the power of 16 over 5. Next, our step is to express the factor with a fractional exponents in terms of radical. So we simplify the fractional exponents in order to get our final answer. So this will become x cubed y, the square root of xy. So the fifth root of x to the power of 16 y6 is just equal to x cubed y, square root of xy. Our second example had an expression of fourth root of a16 b11. So we follow the steps. So this equation will become fourth root of a16 multiplied by fourth root of b11. Step 2, this will become a raised to the power of 16 over 4 times b raised to the power of 11 over 4. Our step 3 is to express its exponent and make it possible divisible by its index. So this will become a raised to the power of 4 times b raised to the power of 8 over 4 plus 3/4. Then we use the step 4 or the laws of exponent, and it will become a raised to the power of 4 plus b squared plus b raised to the power of 3 over 4. Step 5 is to simplify and express the terms into radicals or radical expression. So this will become a raised to the power of 4 b squared fourth root of b cubed. So our final answer is that fourth root of a16 b11 is just equal to a4 b squared fourth root of b cubed. Next example. Cube root of a6 d12 all over b cubed c9. So we use the steps in answering this kind of expression. Again, we're going to use the product rule and the quotient rule. So this will become cube root of a6 over cube root of b cubed multiplied by cube root of d12 over cube root of c9. Second step, write it on a fractional exponent. So this will become a raised to the power of 6 over 3 times d to the power of 2/3 all over b raised to the power of 3 over 3 times c raised to the power of 9 over 3. Step 3 is to use the laws of exponents. So this will become a raised to the power of 2 times d raised to the power of 4 all over b times c cubed. Then multiply to get our final answer, which is a squared d4 over b c cubed. Therefore, the cube root of a6 d12 all over b cubed c9 is just equal to a squared d4 all over b c cubed. In case there is a numerical coefficient in the radicand, express the number as the product of prime numbers or power of primes. First, let us recall prime factorization. For example, 45 has a factors of 5 times 9, and 9 has factors of 3 times 3. So 45 have the prime factors of 3 times 3 times 5, or 3 squared times 5. Let's proceed to our fourth example with an expression of square root of 20 a squared b squared. Here we can apply the prime factorization of our numerical coefficient. So we still follow the steps. So step 1 is to express the numerical coefficient in the radicand as a product of prime numbers. So we have 20. So this is equal to 2 times 2 times 5, or 2 raised to the power of 2 times 5. So the expression will become the square root of 2 squared times 5 times a4 times b squared. Next is to use the product rule. So this will become square root of 2 squared times 5 times a4 times b squared. Next is to write the radical expression into a fractional exponent. So this will become 2 raised to the power of 2 over 2 times 5 raised to the power of 1 half times a raised to the power of 4 over 2 times b raised to the power of 2 over 2. Step 4 is to use the laws of exponent. So this will become 2 times 5 to the power of 1 half times a squared times b. Step 5 is to express the factor with a fractional exponent in terms of radicals. So the expression will become 2a squared b raised to the power of 5. So therefore, a square root of 20a squared b squared is just equal to 20a squared b square root of 5. Let's proceed to our fifth example. So square root of 32x cubed y raised to the power of 15 and z raised to the power of 15. So let's have our steps in solving this equation. So express the numerical coefficient in the radicand as a product of prime numbers as our step 1. So since our numerical coefficient is 32, so it has a prime factors of 2 times 2 times 2 times 2 times 2, or 2 raised to the power of 5. So this will become the square root of 2 raised to the power of 5 times x cubed times y to the power of 5 times z raised to the power of 15. Our step 2 is to use the product rule. So this will become square root of 2 times square root of x cubed times square root of y to the power of 5 times square root of z raised to the power of 15. Step 3 is to write radical expression into a fractional expression with a fractional exponent. So this will become 2 raised to the power of 5 over 2 times x to the power of 3 over 2 times y raised to the power of 5 over 2 times z raised to the power of 15 over 2. Our step 4 is to use the laws of exponent. So this will become 2 raised to the power of 2 times 2 raised to the power of 1 half times x raised to the power of 1 half times y squared times y raised to the power of 1 half times z squared times z raised to the power of 1 half. So step 5. Express the exponent as the sum of the largest integer possible and some fraction divisible by its index. So this will become 2 raised to the power of 4 over 2 plus 1 half times x raised to the power of 2 over 2 plus 1 half times y raised to the power of 4 over 2 plus 1 half times z raised to the power of 14 over 2 plus 1 half. So our step 6 is to express the factor with a fractional exponent in terms of radicals. So this will become 4x y7 z7 square root of 2x yz. So our final answer is square root of 32 x cubed y 5 z15 is just equal to 4x y7 z7 square root of 2x yz. Let's proceed to our final illustrative examples. Example. With an expression of fourth root of 162a8b4c all over 625 of x4y12. So let's go to our solution. Our step 1 is to express the numerical coefficients in the radicand as a product of prime numbers. So 162 has a prime numbers of 9 times 9 times 2, or 3 to the power of 4 times 2. 625 has a prime factors of 5 times 5 times 5 times 5, or 5 to the power of 4. So this equation will become 4th root of 3 to the power of 4 times 2 times a8 times b4 times c all over 5 to the power of 4 times x4 times y12. Step 2 is to use the product rule and quotient rule. So this will become 4th root of 3 to the power of 4 times 4th root of 2 times 4th root of a to the power of 8 times 4th root of b to the power of 4 times 4th root of c all over 4th root of 5 raised to the power of 4 times 4th root of x raised to the power of 8 times 4th root of y raised to the power of 11. Our step 3 is to write radical expression as an expression with a radical exponent or fractional exponent. So this will become 3 raised to the power of 4 over 4 times 2 raised to the power of 1/4 times a raised to the power of 8 over 4 times b raised to the power of 4 over 4 times c raised to the power of 1/4 all over 5 raised to the power of 4 over 4 times x raised to the power of 4 over 4 times y raised to the power of 4 over 4. So let's proceed to our step 4, which is to use the laws of exponent and simplify. So this will become 3 to the power of 1 times 2 to the power of 1/4 times b to the power of 4 times b times c all over 5 times x times y cubed. Our last step is to express the factor with a fractional exponent in terms of radicals. So this will become 3a squared b to the power of 4 square root of 2c all over 5x y cubed. So the expression 4th root of 162a8b raised to the power of 4c all over 625x to the power of 4 y12 is just equal to 3a squared b raised to the power of 4 square root of 2c all over 5x qi cubed. So I hope you have another knowledge on how to simplify radical expressions. Thank you for watching.